Okay, now we're looking at the cubic lattice, and we want to define a few different ways that the atoms can kind of be associated with that three-dimensional structure. So there's two basic categories here. There's primitive lattice, which just has atoms at the lattice points. That's also sometimes called a simple cubic lattice. And then there are two centered lattices, where atoms are at the lattice points or the corners of the cube, but then they're also located in a different position relative to that three-dimensional structure. So let me zoom in a little bit here on the pictures. The first is called the primitive cubic lattice, or again, this is called simple cubic in some places. The atoms are only located on the corners. So we can think of an atom as occupying each corner, each of the 8 corners of that cube. And then if you take cubes like that and stack them all together out into a larger three-dimensional structure, that would describe the positioning of atoms within a primitive cubic lattice. Now, a body-centered cubic lattice, again, there are atoms at the corners of that cube, but there's the additional lattice in the body center this time. So kind of right there in the middle of the structure, there's another atom right there. And again, if we extend this structure out into three-dimensional space, this is our body-centered cubic lattice. And the third one here is called a face-centered cubic lattice. So in this case, in addition to the atoms on the corners, this also has atoms on the faces of the cube. So there's 6 sides or faces on the cube. And you can see there's an atom right there on the center face, one right over here on kind of the right side face, one up here on the top face, right back, left, and bottom as well. So 6 more atoms on the sides of the cube. And these are 3 different possible ways we can think about a structure, a solid structure composed of one type of atom. So this would be very common for things like metals. So most metals will crystallize into one of these structures: simple cubic or primitive cubic, body-centered cubic, or face-centered cubic. Now, what we're looking at here is taking those structures we saw on the last page, where we just have the dots here representing where the atoms are, and we're starting to imagine those as actually 3-dimensional atomic structures. So the primitive cubic structure here, A in the diagram, you can see it's actually the center of the atom that's at each of those points in the cube. And what's interesting and important to recognize here is that part of that atom lies outside of the unit cell that we're looking at. Moving over to body-centered, you can see the atom right in the center of the structure there. That's the body-centered atom. And of course, we have the 8 atoms on the edges or corners of the cube as well. So corner, not edge. Edge is a little different. And then the third one, the face-centered cubic, you can see an atom kind of right here in the front, right on the front face. Each face of the cube here kind of looks like the arrangement of a 5 on a die. So again, atoms on the corners, but also atoms on the faces of the unit cell. And what we're really going to need to do with these structures is start to count how many atoms are present. So let me just read through this slide and I'll zoom in a little bit on the figures. So not every part of an atom on a lattice point is completely within that unit cell. What we want to be able to do is think about how many atoms are actually present in our unit cell, our repeating unit. So coming in up here on the first one, which is the primitive cubic or simple cubic lattice, atoms are only located on the corners. And since the corner is not completely in that cell, you can see in this picture there's only an 1/8 of each of those atoms shown in the structure. That's because the atom on the corner is shared by 8 adjacent unit cells. And that atom's actually going to be cut into pieces, right? And one of the things we're going to want to do is count how much of that atom actually resides in the unit cell. Now, in the body-centered cubic, we still have those atoms on the corners, so you can see those 1/8 of an atom around each corner in that cube. But that body-centered atom, you can see the entire sphere there in the picture. That is completely inside our unit cell. So in addition to the 1/8 atoms on the corners, there's one whole atom in the middle. So I didn't mention that up here, but it's important that there's just one atom in the unit cell for primitive cubic. Body-centered cubic, you've got 2 atoms in the unit cell. So for the corners, it's 8 of them, but only 1/8 of an atom in each case, so 8 times 1/8. For the one in the middle, it's completely inside, so we'd add another 1. 1 plus 1 is 2 atoms in the unit cell. Now for the face-centered cubic structure, we again have the 8 atoms on the corners. So 8 corner atoms, 1/8 of each is in the unit cell. That would give us 8 times 1/8 up here. That's 1 atom present in the unit cell. But if you look at the atoms on the faces, they are kind of cut in half. Half of the atoms in the unit cell we're looking at, half is in the next unit cell over. Since there are 6 of those atoms, that would be 6 times 1/2, or another 3 atoms per unit cell. So a face-centered cubic unit cell, there are 4 atoms present in every unit cell.